All right, physics, special treat for you guys. It's a lab today. We're doing a lab. And you should not watch this video until you have read through the investigation worksheet. We are doing the current balance lab. So step one says to measure out a mass of 1 meter of nichrome wire, and from that measure the mass of each 2 centimeter segment. That won't be necessary for us. We have, check it out, pre-weighted little wires, each one 0.05 of a gram. So all good, step one done. We've got these little teeny tiny, like staple size pieces of metal. Step two, set up the power supply to provide 12 volts to the solenoid. So here's my solenoid, and I'm just going to put that on 12 volts. Seems a little bit irresponsible, but whatever. 12 volts. So positive current's running down there through the ammeter, out the other side. It sneaks in and it goes up here so that the current is spinning around like this. So if I want to know the direction of the magnetic field in my solenoid, I'm going to have to curl my fingers, and they go sort of, the current goes under and then over like that. So my thumb points that way. So the magnetic field inside the solenoid will be that way. Let's check that the current's working there. Oh yeah, 3.2 amps. That's quite a lot. So we won't leave it on very long, but it's working. Step three, don't leave the power slowing for longer than a minute. Check. This will cause the solenoid to heat up, thus increasing the resistance and thus changing the current value that we have there. All right, draw a cross-sectional diagram. So that's up for you guys to do. You need to, like, as if you sliced this thing here in half and showed me the current and the magnetic field. Step four is to set up the whole circuit. There are 2 loops in this circuit. One is the solenoid one, just supplying current to the solenoid, creating that magnetic field. It's DC, so it should be a constant magnetic field. The second loop is for this balance. There's a little seesaw that is attached in there, and that's literally what it is. It's a perfectly weighted little seesaw, and on this side the conducting part sort of comes in off these little hinges for the seesaw, and then it runs along here. Does it? No, sorry, the other side. It goes here, down there, turns 90 degrees, and comes back out. The one on this side is just there to perfectly weight it. It's not actually connected. So current only goes down here, does this U shape, and comes back out. It sits on these little hooks here, which before I started recording, I gave each one a bit of a sand because those contact points need to be nice and fresh. So it sits in there, and it should balance if it's been weighted correctly. So yeah, current comes out, positive current's going to come out here, come down, run down that U shape, then run towards you guys, turn around, come back out, come out these contact points through my ammeter into my variable resistor so I can adjust the current more finely, back home again. All right, all good. So then what do you need to do? Which sections of the current path on the seesaw will experience a force? So what that's asking you is, on my little saw, which parts of the seesaw, the current path, so you've got here, here, and here, which ones will be experiencing a force when a current runs through them in the magnetic field in here? Step 5, you need to record the length of that part. Alright, well, I'll tell you what I'm going to do. I'm going to give you the lengths of both parts, and then you can put the correct answer. So I reckon that long part, what do you reckon? Let's call that 8.5 centimeters. Looks good to me. And then the short part, looks pretty darn conveniently to be 3 centimeters. I'll take it. Right, with no current flowing, check that the balance blade is in a horizontal position. Right, set this guy back up again. Stop shaking. Cool, good enough. It's balanced. I'm happy with that. Turn both currents on briefly to check that the motor force is down. So, all right, so I want the force on this side of the seesaw to be down. So let's think that through. Remember we said the magnetic field inside here was that away. Now I've got my current coming out here, down there, going this way and then coming back. So for the current going this way, in a magnetic field going this way, what I could do is my thumb is the direction of the current on that little bit. My finger's direction of the field, yeah, that should be a force downward. Remember the right-hand rule. So that should work. Oh yeah, so it's getting pushed down here. That's why we're seeing it go up here. Looks good. Step 8, add the first 2 centimeter length of wire. All right, so what we're going to do is we're going to deliberately unbalance our little seesaw. I'm going to add one of those little 0.05 gram staples. And you can see it's unbalanced it. Right? There's a net torque now pushing it down. So gravity's unbalanced it. And step 9, turn on both power packs starting at 2 volts and adjust the voltage of the second power supply upwards until the increased current causes the balance to tip. So I've got a gravity force pushing down here. I want to get my Philby force in here to equal this force. And so I'm just going to bump up the current until I have those two forces in equilibrium. Let's see how this goes. I'm going to try and do it quickly, and you guys should keep an eye on the readings when we get to that critical point.
Good morning, staff, and welcome to Tuesday. Just a reminder that starting at 9:45 this morning, we have our the switch off for 45 sessions. So if you need to get changed or prepared for that, now would be a good time to do that.
All right, so where were we? We were adding our very first 0.05 of a gram to our current balance, deliberately unbalancing it. All right, and now we're going to try and balance it with the Philby force. All right, that's not quite enough current, so I'm going to lower the resistance. Nope, still not enough. Getting there. Ooh, that looks almost balanced. All right, that's too much, so I'll come back. I reckon that is about good. So there's my current. Pay attention to those two values. That looks good to me. All right, now we're gonna add another 0.05 of a gram. And I'm trying to put those 0.05 of a gram on the same spot right at the end there so that they generate, the same torque, same radius. All right, here we go again. I know I'm going to need a little bit more current this time, obviously. Oh. That's pretty close. Yeah, let's call that one. Hopefully you guys were paying attention there. What do I need? 3. That looks good. Right about there. I know it's shaky, so you just have to take your significant figures with a grain of salt. But I'd say that's pretty good. Go up to 4. That looks pretty good. Yep, let's call it there. That looks balanced to me. And one more. 5 data points on our graph. That should be good. I'm also at the lowest resistance I can on here, so I might not be able to get this last one balanced. I'm at 0.1 of a ohm. No, that's as much current as I can pump through there, and it's not enough to lift it up. So, all right, we got 4 data points, and the rest is up to you guys. Good luck. Have fun. Happy quarantine.